Hello, my dear students. This is again Teacher Jenny guiding you to the second module for Quarter 2 of Mathematics 7. So prepare your pen and notebook and together let's make mathematics fun and easy. In this video, we will be learning lines and angle pairs. At the end of this video, you are expected to derive relationships of geometric figures, which includes supplementary angles, complementary angles, congruent angles, vertical angles, adjacent angles, linear pairs, perpendicular lines, and parallel lines using measurements and by inductive reasoning. But before that, let's have first an activity titled Compare. I have here three sets of linear pairs. Now, what you're going to do is to simply compare the given figures. Let us have first this first figure. Describe the two lines here. Very good. The two lines here intersect at a point. Now, how about in this next figure? You're right. Like the first figure, we also have here two intersecting lines. But the difference is that this has a symbol for right angles. Now, how about this third figure? Very good. They do not intersect. Now, these three figures here actually represents our first lesson in this video, which is the relationships among lines. Because in this video, we will be having two lessons. First is the relationships among lines, and second, we have the angle pairs. Let's have the first one, relationship among lines. There are three. The first one here is actually similar with that of the first figure on our activity a while back. So again, we have here two lines that intersect at a point, and that point of intersection is at point P. Now, what do you think is the relationship between line M and line N? Very good. Since they intersect, they are intersecting lines. By definition, these are lines with a common point called the point of intersection. So again, if two lines have a common point, then they are called intersecting lines. Next, we have two lines here, which is similar to the third figure on our activity. Now, what do you think is the relationship of these two lines that do not intersect? It begins with letter P. Very good. They are parallel lines. By definition, they are lines on a plane that do not intersect no matter how far they are extended. So even if we extend them like this or shorten them, these two lines will never meet. Again, we call them parallel lines. Thus, if the first line is named as line M and the second line as line N, we write M is parallel to N in this form. So the symbol for parallelism is a pair of two vertical lines. So this is read as line M is parallel to line N. Now let's have the third relationship among lines. We have here a vertical line intersected by a horizontal line. And on one angle formed by those two intersecting lines is a sign that the angle formed is a right angle. What do you think is the relationship of these two lines, the horizontal and the vertical line? It begins with letter P, 13 letters. Very good. They are perpendicular lines. So by definition, these are two intersecting lines forming right angles. Take note that for perpendicular lines, four right angles are formed. Now, if the vertical line is named as line A and the horizontal line is named as line C, then we write line A is perpendicular to line C. In symbols, we have this one. So the symbol for perpendicularity is an inverted capital letter T. So again, this is read as line A is perpendicular to line C. Now, before we proceed to the second lesson, let's have first an activity titled, Which One? We have here three figures. Now, what you're going to do is to simply identify which one of those three figures shows the relationship among lines that I'll be giving you. Are you ready? Good to hear that. So let's start. Which figure shows parallel lines? Very good. It's figure 2. How about the figure that shows perpendicular lines? Of course, it's figure 1. Now, how about intersecting lines? Very good. It's figure 3. But take note, figure 1 also shows two intersecting lines. But then, those two intersecting lines form right angles. Therefore, they are perpendicular lines. But still, perpendicular lines are intersecting lines. So we're done now with the first lesson. Now let's proceed to the second lesson. We have the angle pairs. We have here an angle named angle A. Now if we copy this angle to form another angle named angle B. Now compare angle A with that of angle B. Very good. Since we just copied angle A to form angle B, that means those two angles have equal measurement. And we call those angles with equal measure congruent angles. Don't get confused with the words equal and congruent. We use the word equal if we are comparing measurements or numbers. But if we are comparing two figures, then we must use the word congruent. So in here, we have angle A is congruent to angle B. Take note, for congruency, we have this symbol. Actually, it is taken from the two symbols. This wavy line here above the equal sign is the symbol for similarity. And when we say similar, we are pertaining to two objects with the same shape. And when we say equal, they have the same measurement. So when we say congruent, these are two figures with the same shape and size. So again, this is read as angle A is congruent to angle B. We are comparing the two angles. But if we compare the measurement of those two angles, then we have this one. The measure of angle A is equal to the measure of angle B. This small letter M here written before the angle is read as the measure of. So take note, we use equal sign in comparing the measurement of those two angles. But if we are just dealing with those two angles, then we use congruent. Next, we have here angle EAS. Now, if we have a ray inside that angle EAS and name that ray AY, there are now two smaller angles formed. We have this angle, angle EAY, and this angle, angle YAS. Now compare those two angles. What is or are common to them? Correct. They both have ray AY. Plus, they have the same vertex, which is vertex A. We call those two smaller angles adjacent angles. So by definition, when we say adjacent angles, these are two angles that have a common vertex, a common side, and do not overlap. So one of the angles formed must not be a part of the other angle. Let's have an example of two overlapping angles. We have angle YAS and angle EYS. So take note, if we're going to compare these two angles, they both have a common vertex. Again, it's at point A, and a common side because they both have ray AS. So take note, these two angles are overlapping angles because this angle, angle YAS, is a part of angle EAS. So again, the adjacent angles here are angle EAY and angle YAS. Next, we have this figure. What can you see here? Very good. They are intersecting lines. Now, given two intersecting lines, we form four angles. Can you name all the adjacent angles here? Okay, we have angle 1 and angle 2. That's the first pair. Second pair, we have angle 2 and angle 3. Third pair, we have angle 3 and angle 4. And the last pair of adjacent angles, we have angle 1 and angle 4. Now, if those are the pairs of adjacent angles, what do you think is the relationship of the remaining angle pairs? We have first angles 1 and 3, and second pair we have angles 2 and 4. Very good. They are opposite angles. And those opposite angles, when two lines intersect, are called vertical angles. By definition, these are opposite angles formed by two intersecting lines and facing opposite directions. So again, in this figure, the pairs of vertical angles are angle 1 and angle 3, and angle 2 and angle 4. Next, we have this figure. Take note again. In here, we have a pair of adjacent angles. Can you name them? Very good. We have angle LVE and angle LVO with a common ray, ray VL. Now, can you name the two non-common rays of those two angles? Very good. We have ray VO and ray VE. Now, considering those two non-common rays of the two angles, angle LVO and angle LVE, what was formed? Very good. A straight angle or a line was formed. That's why we call the two angles, angle LVO and angle LVE, a linear pair. By definition, these are two adjacent or consecutive angles which measures 180 degrees. Or in other words, when we say linear pair, these are two adjacent angles whose two non-common rays form a line or straight angle. That's why the sum of those two angles should be equal to 180 degrees. So if the measure of angle LVE is 77 degrees, what is the measure of angle LVO? Very good. It's 103 degrees. That's 180 minus 77 degrees. So again, angles LVO and LVE form a linear pair. Now, considering the same figure, aside from forming a linear pair, those two angles are also called supplementary angles. Because when we say supplementary, these are two angles whose sum is 180 degrees. So since if we add 103 plus 77, that is equal to 180 degrees, then they are supplementary angles. But the difference between a linear pair and supplementary angles is that supplementary angles can also be non-adjacent angles. Like this example. We have here two angles, angle A and angle E. Take note, they are not adjacent angles because they do not have a common ray. But still, they can be considered supplementary angles as long as the sum of their measurement should be equal to 180 degrees. So if angle A measures 134 degrees, what should be the measure of angle E to make them supplementary angles? Very good. It must be 46 degrees in measure. So again, in here, angle A and angle E are supplementary angles because their sum is equal to 180 degrees. Now, what if we have a right angle here, angle MAT, and we have a ray that divides that right angle into two smaller angles? We have angle MEH and angle HAT. If we add those two smaller angles, what is the sum? Very good. The sum is equal to 90 degrees, or it is equal to the measure of a right angle. So if we add the measure of angle MAH plus the measure of angle HAT, that is equal to 90 degrees. Now, if the sum of two angles is equal to 180 degrees, we call them supplementary angles. But if the sum of two angles is equal to 90 degrees, then we call them complementary angles. By definition, these are two angles whose sum is 90 degrees. Like supplementary angles, complementary angles can either be adjacent angles or non-adjacent angles. So for this example, if the measure of angle HAT is 63 degrees, what should be the measure of angle MAH? Very good. It should be 27 degrees to make the sum equal to 90 degrees. That ends our discussion for lesson 2 on angle pairs. Do you have questions? If you have, don't hesitate to. If you have, kindly type them on the comment section. Now, before we end this video, remember that there are three relationships among lines. We have the first, intersecting lines. Second, parallel lines. And last, we have perpendicular lines. For angle pairs, we have congruent angles, adjacent angles, vertical angles, complementary angles, supplementary angles, and linear pairs. That's all. I hope you have learned a lot from this video. Thank you for watching. Goodbye.